So this question, we've got isotopes. And if you remember, definition for isotope is they have the same number of protons but a different number of neutrons. That's a bit of a core knowledge fact to remember in here. But then got some information given, and they want us to find the number of protons, electrons, and neutrons. Now, the way they've set this out, there's a little trap just to be aware of, because the mass number goes at the top and the atomic number goes at the bottom. So that one doesn't matter too much. But over here, for isotope B, that's going to be a mass number of 2 and a atomic number of 1. If it helps you to write that like that, you can do that. So remember, the number of protons is equal to the bottom number, that's the atomic number. So this has got 1 proton, as has this isotope. The number of electrons is equal to the number of protons in an atom. So that's going to be 1 electron and 1 electron over there. And then the number of neutrons is the mass number minus the atomic number. So this one is 1 take away 1, so it's going to be 0. And this is 2 take away 1, so it's going to be 1. Okay? Carrying on, we're then told that we've got a fuel cell working away here. And the question goes on to ask us to describe what figure 2 shows about the voltage and how the voltage varies over time. Whenever you get a question like this linked to a graph, you must always include numbers in your response. So use the data from the table in order to get your answer across to them. So what I'm going to look at here is I can see that this is actually at 1.1, a reading of 1.1 volts, and it stayed at 1.1 volts for 60 minutes. So my first mark is going to come by saying to them that the voltage is 1.1 volts for the first 60 minutes. Okay, and that's going to get me one of the marks from the question. I'm then going to look at what happens here, and you can see that the voltage drops. So it drops from 1.1 to 0, and it takes 15 minutes. It goes from 60 to 75 in order for that to drop. So my next mark is going to be that at 60 minutes, the voltage drops from 1.1 volts to 0 volts, and then we can say in 15 minutes. Okay, so we've got ourselves 2 marks, and we referred a lot to the data from the graph. Next one here, we've got a chemical cell made by electrodes. So here are the electrodes in the electrolyte. And it says, why is sodium not suitable for this experiment? So sodium, we're using an aqueous electrolyte. So aqueous means it's in H2O, and hopefully remember the basic chemistry that sodium would react very violently with the water. So when you say here is that sodium would react with the water. The second thing, sulfur is a non-metal and it does not conduct electricity. And if I want to use an electrode, a material for an electrode, it has to be able to conduct. So they have to be good conductors. So my second reason here is sulfur will not conduct electricity, and that's why we don't use sulfur.